All right, this video is going to cover solving logs. So you definitely need to know your properties. So if you haven't seen the properties of log video, I would recommend starting there. But let's go ahead and get started. Basically, the easy ones are like number one, where you're just going to snail this. And so you're taking it to exponential. And so you're like, okay, 2 to the 3 equals 2x plus 1. And then you just go solve it. Now, I will say with these solving logs, you must check answers. Now, you're not checking them for necessarily values or anything. All you're checking is negative logs, because you can't do like if it was log base whatever of -5. You can't do that. You can't do logs of negatives. This is what you're checking for. So like real quick, if you just imagine in your head, if you plug a 7/2 in there, it's not going to be a negative number. So this answer is good to go. That's all I'm referring to when I say you must check answers. You need to check every single one of these answers though for a negative exponent. So the next one's not so bad. Let's look at number 3. Snail it. And so you're like, okay, 3 squared equals x squared plus 1. So that's 9. Subtract 1. And so you would root it. You would need to check the positive and negative of this. Now, when you plug this in here, it's squared inside that parentheses, so it's going to turn positive. So I would leave both of these answers in this scenario. Okay, let's look at number 4. You would snail it, and so you're like, okay, 5 squared equals x squared plus x plus 4. This is 25. This is a quadratic that you need to solve, so try to make it equal to 0. And then you try to factor it. This one's not going to factor. So when that happens, you have to run the quadratic formula. So it'd look like this. And then this 1 plus 84 becomes 85. So I'd probably leave it like this. Now, unlike the quadratic formula ones, it's kind of difficult to really tell if it's going to be positive or negative. I would probably just leave this answer. It'll be obvious when the answer gets tossed. We will see 1 or 2 of those. So you'll see what I mean. Now, look at number like 5. This is where they start putting rules in here. So it's really like you need to rewrite this problem with these exponents like this. So it's really like log base 3 of x to the 1/2 is the same thing as root x. And then log base 3 of 2 squared is 4. All right. And so you end up with this right here. And so basically now all you have to do is say, okay, well, root x equals 4 and then square both sides. X equals 16. Okay, now let's look at number 7. Take care of these numbers in front. They become exponents. So really you have log base 5 of x squared equals log base 5 of 4 cubed, which is 64. So really you can just think about this as like x squared equals 64. And so you root it and you're like, okay, x equals plus minus 8. Now, here's what I'm talking about. If you check this answer, which, by the way, you must check the answer with the original. So here's the original. Okay. If you check 8 with the original right here, it's good. But if you check -8 with the original, it's a log of a negative number. That is not allowed. This answer gets tossed. X equals 8 is your only answer. So that's what I was talking about earlier. Okay. All right, so the next ones of those are pretty self-explanatory. Let's look at number 8, I guess. Move the 3 in front, it becomes x cubed there. So it's like log base 2 of x cubed equals, move this negative, make it 27 to the negative 1. So 27 to the negative 1 is 1 over 27. So you're really sitting there with like x cubed equals 1 over 27. So your answer is 1/3. All right, now let's look at like number 9, where they start applying more rules. Right at the start of number 9, I see this 3 in front. Well, that's going to become a cube here. And so basically you're looking at this. You're looking at log base 2. It's a log plus a log, which means I can multiply those. So it's like of 4 times that x minus 1 cubed, like that. And this equals 5. Okay. And so now you're like, okay, well, I can snail this and go 2 to the 5 equals 4 times x minus 1 cubed. 2 to the 5th is 32. Divide by 4. Cancel that cube by cube rooting. And then finish solving. That's how you would handle that problem. And by the way, in terms of checking your answer, if I end up with a positive answer, 90% of the time, I'm not going to check it. It's really just when I get like a negative answer. Like, let's look at number 11 next. Okay, on number 11, I see log plus log right from the start. So I'm going to multiply those and call it 1 log. So it's like log of, and I'm going to distribute this x because it was like x times x plus 15. I'm distributing this. That's how I'm going to get to x squared plus 15x. Okay, and this equals 2. Now, you're going to have to go to snail this to convert it to solve it, but you need the base. The base is missing, so it's a 10. So it's really like 10 squared equals x squared plus 15x, all right? Now it's a quadratic that you're trying to solve, so make it equal to 0. That way you can try to factor it. This one does factor. So you're going to get answers of x equals negative 20 and x equals 5. Well, you better check them, because if you plugged in, just look right here, right at this part. If you plugged in negative 20 there, it's log of a negative. So this answer gets tossed. Your answer is only x equals 5. So that's how you're going to do the majority of these. Now, some of them get kind of tricky towards the end there. So let's look at some of these. All right, let's look at like 27's a good one. Okay, on 27, you have a log minus a log. So I'm instantly going to call that 1 log and divide them. So it's like x minus 1 over x plus 6, okay? Equals, and I do the same thing on the other side because it's log minus log. So it's like of x minus 2 over x plus 3. Now we got log base equals log base. So we can really just think about it like this, like x minus 1 over x plus 6 equals x minus 2 over x plus 3. Okay, you're going to have to cross multiply to solve this. Now, these are binomial times binomials. That means you will be running FOIL. So when you do the x minus 1 times x plus 3, you get x squared plus 2x minus 3. That's a 3. When you do the x minus 2 times x plus 6, you get x squared plus 4x minus 12. All right, now it's a quadratic you're trying to solve, kind of. So get everything to one side. So I'm going to move everything this way. So I'm going to minus x minus 2x plus 3. It's x squared. Minus x squared minus 2x and plus 3. So basically you're going to get 0 equals, these guys cancel. And so it just makes 2x minus 9. Now it's super easy to solve. So that's how you would handle that problem. Okay. All right, now look at number, let's do 29. First thing I see is log minus log, so I'm going to divide them. And then it equals -1. Okay, now this part right here, you can GCF an x out of the top and an x out of the bottom. And these x's can cancel. And so basically this problem turns into log 1/3 of x plus 1 over x minus 1 equals -1. Now you're ready to snail. So you get 1/3 to the -1 equals that x plus 1 over x minus 1. Well, 1/3 to the -1 is 3. Call it 3 over 1. The reason you call it 3 over 1 is because now you're going to cross multiply to solve this. Well, when you do this 3 times the x minus 1, you must distribute the 3. Then you just finish solving. Just like that. Okay. And then we'll do one of these difficult ones. Let's do 33. That'll be the last one. When I look at 33, I see log minus log, so I'm going to go ahead and make them 1 log. Just like that. All right. Now, I've already messed up. And where I messed up is you can't do that rule if these log bases are not the same. These are not the same. So you have to get it to log base 2. So let me write the original. Let me show you how to do this. All right, this right here is the problem. So basically what you're going to do is, I hate to say root it because I'm not 100% sure on that, but I'm going to root it. I don't know if that's the correct term though, like rooting it. I think it's more of like half this exponent, half this one, which is rooting. I'm not sure. But anyways, I'm going to root it. So it's going to become this. Okay, now it's a log minus log with same bases. So I can go ahead and combine them using that rule. All right, so it'd look like log base 2 of 3x plus 2 over root x equals 3. Now you can snail it. Change 2 cubed to become 8. And I would even write it as 8 over 1, because what you're going to have to do now is cross multiply. So you got 8 root x equals 3x plus 2. All right, now this root is going to bother you, so square both sides. So on the left, it becomes 64x. The 8 gets squared too. on the right, you have to run FOIL to get 9x squared plus 12x plus 4, okay? And so now when you're here, make it equal to 0. This does not factor, so you have to run the quadratic formula. When you do this root part, you should get 2,560, which does break down to become 16 root 10. It's 256 times 10. And so now you can reduce. And so you'll get, these are all divisible by 2. So you should get 26 plus minus 8 root 10 over 9. That's a hard problem. So that's how I would have handled it, though. Anyways, I'm sitting here debating if I should show you 34 or not. Let's go ahead and do 34. All right. I see log plus log plus log, but they don't have the same bases. So here's how I'm going to do this. I'm going to, let me write it out. Okay, I want to get all of these things to say log base 2, okay? So here's maybe how I should have explained it earlier. If you can, I guess it is kind of like a square root. So like this one, to get it to 2, it would have to be a 4th root, meaning it's going to be to the power of 1/4 here. This 4, to get it to a 2, it's going to be a square root, meaning it would be a power of 1/2 there. And then the third one's good to go. So it really looked like this. These are base 2 now, and it's like x to the 1/4. It's base 2 now, and it's like x to the 1/2. All right, now I have log plus log plus log, and all the bases are the same, so you can call it all 1, and you multiply these things, right? Like x to the 1/4 times x to the 1/2 times x. Well, that means you're adding these exponents. Like that. So when you do this, you get 7/4. All right, now you're ready to snail. All right, now to solve this, here's what I did. I'm basically going to 7th root both of these things. 7th root both of these things. You can do this. I mean, it's just a mathematical move that you're applying to both sides of the equation. 7th root, it's just like when you square root both sides, same thing. So it becomes 2 equals this part right here. It's as if it said 7/4 times 1/7, which is just going to be 1/4. So this part becomes x to the 1/4. So now I'm going to the power of 4 both sides. It's like squaring both sides, but it's to the power of 4 now. So you're going to end up with 16 equals x. Hope that made sense. This one was a very difficult problem because you had these base changes. Then you had to add this correctly. Then you had to realize that you can 7th root both sides and 4th power both sides to get to your answer. So that's a very difficult problem. All right. Hope this video helped.